Hey everyone, welcome to the PT Simplified channel. Have you ever wondered why your biceps looks like a spindle while your chest muscle looks like a fan? It's not just for aesthetics. The shape of a muscle determines exactly how much power it has, how far it can move, and how fast it can contract. Today, we are breaking down muscle architecture in a way that actually makes sense. Let's simplify this. Before we dive into architecture, remember that we have three types of muscle tissues: cardiac muscle, smooth muscle, and skeletal muscle. Cardiac muscle is the involuntary muscle which is found in your heart walls. Smooth muscle found in organs and blood vessels. Now think about this. Why the biceps can move the elbow so fast and the calf muscles can lift your entire body weight? The answer is not muscle size, it's muscle architecture. Muscle architecture refers to how the muscle fibers are arranged relative to the tendon and the line of pull. This arrangement determines the force production, range of motion, and speed of contraction. So, architecture basically decides what a muscle is best designed to do. There are two main types of muscle fiber arrangement: parallel and peniform, which is also called pennate. In parallel muscles, the muscle fibers run parallel to the long axis of the muscle. Now let's see the structural characteristics of parallel muscles. Muscle fibers are long and the fiber length is almost the same as the muscle length. To understand better, muscle length refers to how long the entire muscle is, and the fiber length refers to how long the individual fibers inside the muscle are. So, when a parallel muscle contracts, most of its total length is actively shortening and very little length is wasted in the tendon. It has small physiological cross-sectional area. Physiological cross-sectional area refers to how thick a muscle is. It is the best predictor of muscle strength. If physiological cross-sectional area is large, then more fibers pull together, which results in more force production. But in parallel muscles, physiological cross-sectional area is small, so force production is lower. So, the functional outcome of a parallel fiber arrangement is large range of motion, faster shortening velocity, and less force production. That's why muscles like the biceps are great for quick, fast elbow flexion, but they are not designed to generate massive force like your glutes. Next, we are going to see types of parallel muscles. The first one is flat muscle. Think of them like a broad sheet spread over an area. They are thin and wide, often attached using a flat tendon called an aponeurosis. Since they are wide, their force spreads over a large surface area. The example is external oblique muscle. This muscle forms the side wall of your abdomen. Second one is fusiform muscles. These are the classic spindle-shaped muscles. It has thick middle part and narrow ends and also has a prominent muscle belly. They allow strong contraction with good range of motion. The examples are biceps brachii and brachioradialis. The third one is strap muscles. These look like long ribbons or straps. These muscles are long and narrow and has same thickness from beginning to the end, and it has no big bulging belly. They mainly produce direct controlled movement. The example is sartorius. The fun fact is it's the longest muscle in the body. The fourth one is convergent muscle. These look like a fan shape. It has broad origin and fibers come together into a one tendon. Because fibers come from different directions, they can produce strong and versatile movements. The examples are pectoralis major and trapezius. The fifth one is circular muscles. These are arranged like a ring. Fibers run in circles and surrounds the body openings. It acts like a spinsters. They open and close passages. The examples are orbicularis oris around the mouth and orbicularis oculi, which is present around the eye. In summary, parallel muscles are movement muscles which has speed and range of motion. The next one is pennatiform muscles. In pennatiform muscles, the muscle fibers run diagonally to a central tendon, giving a feather-like appearance. The structural characteristics of pennatiform muscle fiber arrangements are: the fibers are short. Here, fibers do not run the entire length of the muscle. They attach obliquely to a tendon or a aponeurosis. The second one is muscle length is not equal to the fiber length. In pennatiform muscles, muscle length is much greater than the fiber length. So, when the muscle contracts, only the short fibers shorten, not the entire muscle. And it has large physiological cross-sectional area because fibers are short and angled. Many more fibers can be packed into the same muscle volume. This increases the physiological cross-sectional area. And remember, large physiological cross-sectional area is equal to greater force. So, the functional outcome of a pennatiform fiber arrangement is greater force production, smaller range of motion, and slower contraction speed. That's why your calf muscles can push your entire body weight during walking. They are designed for power. Next, we are going to see types of pennatiform muscle. The first one is unipennate muscles. Imagine a feather where fibers are present on only one side of the tendon. The fibers attach to one side of a central tendon and looks like a half of the feather. For example, extensor digitorum longus and tibialis posterior. These muscles are strong but still allow moderate movement, useful for control limb actions. The second one is bipennate muscles. Now imagine a full feather. Fibers on both sides of the tendon. The central tendon is in the middle and the fibers attach on both the sides. Looks symmetrical. The example is rectus femoris and gastrocnemius muscles. Because fibers are packed on both the sides, these muscles can generate more force than the unipennate muscles. The third one is multipennate muscle. Now think of many feathers joined together. The fibers attach at multiple angles and several tendons within the muscle are present. And very complex arrangement is there. For example, deltoid and gluteus muscles. These are usually very powerful muscles because so many fibers are packed into a small space. In summary, pennatiform muscles are the power muscles. It has both strength and force production. Apart from this, there are special muscle shapes, which is quadrate muscle, multi-headed muscle and multi-bellied muscles. Quadrate muscle has 4 equal sides. The example is rectus abdominis muscle. And the multi-headed muscles has more than one origin. Example, biceps which has 2 heads, triceps which has 3 heads and quadriceps which has 4 heads. The last one is multi-bellied muscles. It has more than one muscle belly. For example, digastric muscle. This is why power muscles are trained differently. Rehab loading varies by muscle and some muscles fatigue faster than the others. Muscle architecture guides exercise selection, rehab progression and performance training. So, in final summary, the main function of parallel muscle is speed and range of motion, and the pennatiform muscle is force and strength. If muscle architecture finally made sense today, hit like and share with your classmates. And don't forget to subscribe the PT Simplified channel. Here we don't memorize things, we understand it. I'll see you in the next one.